Welcome back to my channel. Today we are going to be discussing a two-pointer pattern. Now this two-pointer pattern is a pretty popular pattern that is used for searching, right, or doing some query within a particular problem space. The idea is that we have two pointers, maybe a left or a right pointer, and then continuing to expand or contract across a space. So usually this space could be a linked list, and sometimes it could actually be an array. Yeah, so we're going to take an example now. A pretty popular problem is the problem of finding the midpoints of a linked list. Yeah, so when I say finding the midpoints of a linked list, so in this question, the idea is you have a set of nodes within a linked list such that every node has a single pointer. Every node has a single pointer to the next node. So this is an example of what a linked list might actually look like in memory. So this is a linked list now of size 4. Let's make it 5. Yeah. So in this case, you need to now find the midpoint of this linked list. And the idea is, ideally, what you will probably do is to say that, okay, let's first count how many nodes are in this linked list. Yeah. And then that will mean we are going to move from here. Start from here. Count, this is 1, this is 2, this is 3, this is 4, this is 5. Yeah, then knowing that we have 5 nodes in this linked list, we know that the midpoint should most likely be at the position of 5 over 2. Yeah, so that's roughly like n over 2, where n is the size of this linked list. Yeah, so now this is 2.5, and then with integer divide you have 2. So definitely the node we are looking for is at the position index 2. Now this is index 0, this is 1, this is 2, this is 3, this is 4. So definitely this is our middle. That's pretty clear. So you can imagine we do that for a very long linked list, say a linked list of about 100 nodes. You could do the same operation. However, there's no need to go through these two passes, right, to eventually get out the node at the middle. You can do this in one sweep. That's where the two-pointer pattern shines. So in this case, we would have 2 nodes. So instead of having just one, node, we'll have 2. So in addition to this, we'll have another one. So node 1 and node 2. So let's say I paint this one red. Yeah, so we'll have we'll have 2 pointers, so a left pointer and a right pointer. Or in this case, we could say you could have one that is slow and one that is fast. Now, initially, both pointers will start at the first index. Initially. Then, what will now happen is, for every iteration of the loop, the slow pointer will move 1 position ahead, while the fast pointer will move 2 positions ahead. And then for the next iteration, the slow pointer moves 1 position ahead, the fast pointer moves 2 positions ahead. We do this until the fast pointer gets to the end of the list. Now, once the fast pointer gets to the end of the list, at that point, we can be able to say that where the slow pointer is definitely the middle. And you can see we do this in a single sweep through the linked list. This is the power of the two-pointer pattern. Another popular question is a question that relates to finding a cycle within a linked list. You can probably attempt to do that, but let me just draw what that might look like. So it could be something like this. So this could be the linked list. We have some set of nodes that are linear, and then at some point you might now have some form of cycle. Yes, yes. And as we can see, there is some form of cycle within this linked list. One question could be, okay, so find if this linked list contains a cycle, or find the node that represents the cycle. In this case, it's pretty obvious for us to see that this is the node where the cycle begins, and then this is the entire cycle. So the question could be of the form of finding the node that it represents the cycle, or find the nodes that are within the cycle. This problem can also be solved with a two-pointer pattern. So I would like you guys to just review it and then try to come up with a solution. Another popular problem which is important for me to discuss is a two-sum problem. This another popular problem is called two-sum, and usually the two-sum could be done on a simple array, and the question goes in the format, find two values whose sum equals a target value. So you could imagine that you are given an array of let's say an array of size 9, right? So let's say we are given an array of 3, say we are given 3, 5, we have 6 in this array, we have 9, say we have 11, we have 21, we have 33, say we have 41, this is already size, and then this is 44. Yeah, and then you're given this array, and then you are told to find, and you're given a target of, so you're given the array, this is the array, and you're given a target of 17, and you're supposed to find two values within this array that sum up to 17. So naturally, how will you do that? Usually you would probably say, let's us, you probably have like some form of two for loops, whereby there will be an external for loop that will first loop through I is equal to 0 all the way to I is equal to the length of this array. Yeah, so the length of the array. You do something like this, then you now have another internal loop that will go from j is equal to, we could go from j is equal to I plus 1 all the way to the length of the array, and then you now do a comparison of array of I plus array of j, check if it's equal to target. Now if this equals to target, then you return this value. Yeah, so this is how you naturally do it. However, this is pretty time consuming, and actually this is going to loop through the array the first time, and then to loop through the array a second time within the first loop. And definitely this is an n squared solution. So now this is bad. This is pretty bad. We can actually do better than this. We don't have to loop through this array twice. And this is another point where the two-pointer pattern actually shines. So one thing we can notice about this input array is that there is some form of order in this input. It's sorted. You can see this is 3. 3 is the lowest number inside this input. 44 is the highest, and everything in between is in the order of increasing. It's in an increasing order. We can actually use that to our advantage and say that, assuming we have our left pointer now pointing here, and we have a right pointer at this position, what that means for us now is that we have a left and we have a right pointer. What we can do is we keep a left pointer at this first position and keep a right pointer at this first position. Yeah, then we sum up the two values at those positions. If the result of our sum is a value that is more than the targets we have to look for. That automatically means that we need to reduce the result of that sum. Yeah, just like you guys take a minute to think about that. So now in this case, we have the left pointer is pointing at 3, and then the right pointer is pointing at 44. So we have 3 plus 44. Let me change this to black. So 3 plus 44 gives us what? That gives us 47. 47 is a number that is higher than the 17 we are looking for. So that means we need to find a way to make sure that this sum reduces. And we can do that because we know that the elements here are in an increasing order. So what do you guys think? Do you think that we should move this left pointer from 3 to 5? Or we should move the right pointer from 44 to 41? I mean, we can just check. It's actually not much of a big deal. Let's just check. So let's move this left pointer from 3 to 5. So that means that we'll have this here. So this pointer will be here. And that will mean that we're now going to be summing 5 plus 44. This gives us 49. 49 seems to be larger than 47. Okay, maybe we did the wrong thing. Let's move the other pointer from 44 to 41. Now in this case, the sum becomes 3 plus 41. And 3 plus 41 gives us a value of 44. And actually 44 is less than 47. So this means that with 2 pointers, we can have one pointer on the left and one on the right. And then if we sum the values pointed by those pointers and we have a value that is more than these are targets, we should move the pointer that is on the right towards the left so that we can reduce this cumulative sum. So that's a very important point of this approach. Yeah, so here now we have this. We see that we have 44 as a sum, and we can continue to repeat this process over and over. Now 44 is more than 17, so we also reduce we also bring the right pointer towards the left. Now this is 3 plus 33, we have 36. That is still more than 17, so we move this over to the left again. Now this is 3 plus 21, this is 24. That is 24 is still more than 17, so we move this over to the left. So now this is 3 plus 11. 3 plus 11 gives us 14. So this is another important point. So now we have 3 plus 11. 3 plus 11 gives us 14. 14 is less than the targets that we are trying to achieve. That means that we now need to sort of like find a way to increase the cumulative sum. And to increase the cumulative sum, remember what we did initially is to now move this left pointer from where it is towards the right. So now the left pointer is pointing at 5. 5 plus 11, that gives us 16. 16 is still less than 17. So we move the left pointer again towards the right. Now the left pointer is on 6, the right pointer is on 11. The sum of both 6 plus 11 gives us 17, which is exactly equal to what the number we are looking for. So we have 6 plus 11 gives us 17. At this point, we can easily say this is the value we are looking for. And then immediately we return back these values and return back an array of 6 and 11. So if it happens that this sum does not exist in this entire array, what will happen at the end of the day is that at some point the left pointer is going to overlap the right pointer, or the right pointer will overlap the left pointer. In such a case, we would have realized that we did not get the sum of the values we're looking for. So I hope you guys have benefited from this pattern. This is a very important pattern that is pretty popular in some algorithmic problems. It's called the two-pointer pattern. I'd like you guys to take some time to actually practice some questions based off of this pattern, and I'll be sharing some in the description. Alright, thank you very much for coming around once again. See you guys in the next video, where I'll be discussing the next pattern on this list, the sliding window pattern. Thank you very much. Don't forget to like, share, and subscribe. Bye guys.